Hello, welcome back. Welcome to the second video of Mojo Jojo lectures. Today we'll be dealing with the same topic, fluid, a bit more advanced. First of all, you might have heard this person when it comes to physics. He's a person who contributed a lot to fluid dynamics, pressure, and he contributed a lot that the SI unit of pressure is Pascal. So what is Pascal's law? If I'll read Pascal's law right now, if any external pressure is added to a fluid, it is distributed throughout the fluid equally. I'll write that down. If any external pressure is added to a fluid, it is distributed equally. So now that is Pascal's law. Now, as you know, the SI unit of pressure is Pascal, which is represented as PA, an uppercase P and a small case a. That is the SI unit of pressure. Now, what is actually 1 Pascal? And as you know, pressure is equal to force by area, right? So now we are actually going to derive the unit for pressure, which is equal to force is equal to a Newton, right? Whereas area is equal to meter square. Therefore the unit of pressure is Newton per meter square. So 1 Pascal is equal to 1 Newton per meter square. I'll put that in a box. It is quite important because you might sometimes feel that 1 Newton per meter square is not 1 Pascal, and 1 Pascal is something different, and you often get confused with atmospheric pressure. Let me rub this off. Okay. 1, 2. Okay. Now you might have heard the word atmospheric pressure, or ATM. Now what is this ATM? ATM is also pressure, but it is a specific amount of Pascal. I'll write it down. 103,000. Yes, 1 ATM is equal to 103,000 Pascals. Now that is quite important. It comes in most problems related to reality. In problems related to reality, or problems, related to air, most of the time this atmospheric pressure comes out. And if you don't know what is 1 atmospheric pressure, and always the SI units are used, so you need to first convert it to Pascals for other values. So you now know what is 1 atmospheric pressure. Now let's do a problem to show that the force is not equal. I'll rub this off. You don't mind me rubbing this off, right? Even though I just wrote it. Big thing. Okay, now we'll consider some figure. Sorry, control. whose two things, two types of two pressures exerted. So consider that A1 is equal to 4 meter square. You just I'll just dot figure, kind of tends to be a hard dot figure. The same figure I drew at first. Yeah, same one. The same one exactly. So we have fluid over here, and unlike last time, this time let it be water. Okay. So the area of this is 4 meter square, right? And let area 2 be 6 meter square. Not writing out over here, consumes a lot of time. So so what I derived in the last video is that the pressure input is equal to the pressure output, right? Just put it in a box just so you remember it. Sorry, wrong tool. Yes. Okay. Now consider that a force, an F1 of 40 Newton. No, actually you don't have to consider that. Hold on. We don't have to consider the force. Wait, let me rub that off. Sorry. Okay, consider a pressure. A pressure, set P1 is equal to P2 or P out. Let it be, suppose, 10 pascals or Newton per meter square. So what is pressure, force over here? Let's consider F1. So as you know, P is equal to F by A, right? Pressure is equal to F by A. That's not a draw, it's P. P is equal to F by A. So what is F? F is equal to P into A. So F1 will be equal to P into A1, right? P into A1. What about F2? F2 will be equal to P out into A2, right? Okay, now we'll just do this. What is P1, P in into A1? P in, we have it as 10 pascals, and A1 it is 4 meter square, right? So 10 into 4, 40 Newton, right? A1 into P1. P1 is equal to 10, A1 is equal to 4. Now what is P out into A2? As you know, the pressure is same, it is 10 into 6, right? So it comes as 60 Newton. Now that's something strange, right? You see that the pressure is same. Oops, that's not what I meant. Let me undo that. Yes. So what can we infer from this? From this we can say that F1 will not be equal to F2. So if we apply a force over here, it won't be equal to the force exerted by the fluid. But the pressure is same, right? Pressure is same, but the force not equal. So we can write it down. Same thing again. Not equal to F2. Yes. Oops. Not what I meant. Yes. Make it a bit more important. So the force is not the same always. So I think my time is full right now. So see you in the next video. Please do watch our next video, it's quite important. Thank you.